Welcome back to class. I was saying that there are basically three steps that are involved in electrolysis. So the first one, as we have discussed already, we have ionization of electrolyte and water. So the electrolyte undergoes ionization to release the ions, and then that depends on whether the electrolyte is strong or weak. Also, we undergo ionization to giving our hydrogen ions and then hydroxide ions. Now, before I continue with that, let's take a look at this, what I have at this left hand corner. The differences between a conductor and an electrolyte. A conductor is always an element, an electrolyte is always a compound. Now, a conductor, the electricity carriers in conductors are electrons, while the electricity carriers in electrolytes, they are free mobile ions. Now, the third one, a conductor does not decompose upon the passage of electric current, but for an electrolyte, it decomposes to break into ions when electric current passes through it. So let's continue with this. So these processes, we have ionization of electrolytes and water, and then the second one, migration of the ions to the electrodes, as we have said before, cations to the cathode, anions to the anode. So we have cations positively charged to the negative electrode, which is cathode, and then the anions negatively charged ions to the positively charged electrode, which is the anode. Now, don't let us forget that reduction occurs at the cathode, while oxidation occurs at the anode at all times. In all cases, oxidation at the anode, reduction at the cathode. Now, what is the next step? Discharge of ions at the electrodes. That's the third step. So in case you are given a question that you should try and then do a kind of chemistry on the electrolysis of a certain electrolyte. So you need to follow these steps so that you will not be making mistakes. The first step is that the electrolyte must ionize to give you its ions. And then water must also ionize to give you hydrogen ions and hydroxide ions. Then the second one, the ions will migrate to the electrodes, to their respective electrodes. Cations to the cathode, because cations are positively charged, so they will migrate to the negatively charged electrode, which is the cathode. Now, anions are positively charged, they migrate to the what? Anode. Anions are positively charged, anions are negatively charged, so they migrate to the anode, which is the positively charged electrode. Now, for the discharge of ions at the electrodes, after the ions must have migrated to the electrodes, we now have what we call discharge of ions. Now, if you look at this, for example, we have our sodium ion here, hydrogen ion here, and then we have our chloride ions and then hydroxide ions. Now, out of these two ions that are going to migrate to the cathode, only one of them will be discharged. Now, that's what we call preferential discharge. And then that preferential discharge is guided by some factors, which are mainly three. So in case you are being asked that, okay, which ion will be discharged at the electrode as maybe cathode or anode, you need to understand the factors that affect preferential discharge of ions to know the one that will actually be discharged. Now, so these are the factors that are involved in the preferential discharge of ions at the electrode. The factors that affect preferential discharge. So there are three. We have number one, position of the ion in the activity series. Position of the ion, that is the ions we are trying to talk about, the position in the electrochemical series or activity series. Now, if you check these ions here, these two that are migrating to the cathode, we have sodium and hydrogen ions. Out of these two, one will be discharged. One will be discharged at the expense of the other. So how do you know the one that will be discharged out of these two at the cathode? Don't forget, both of them are moving to the cathode, while the chloride and hydroxide ion, both ions are moving to the anode. So out of the two, one will be discharged. So how do you know the one that will be discharged? So you need to understand these factors. So the first one is position of the ion in the activity series. Now, there's what we call activity series, and the activity series is the arrangement of ions according to their reactivities, how reactive they are. Now, we have the activity series for the positive ions, that is for the cations, and then we also have the activity series for the anions. Now, I'll be giving you a detailed representation of the activity series so that you know what we are dealing with. Now, I'll be drawing them at this side of the board. Now, for the cations, you are having your common ions that you are familiar with. This is K+, Na+, we have Ca2+, that is calcium ion. Then there is magnesium ion, Mg2+. Then we have aluminium ion, Al3+, zinc 2 plus, Fe 2 plus, H plus, Cu 2 plus. We have Hg 2 plus, and the likes, even till gold and the likes. Gold is Au3 plus, silver is Ag plus. Now this is for the cations. Then for the anions, we have our F minus. This is our fluoride ion. Then we have SO4 2 minus. We have SO4 2 minus. We have NO3 minus. We have Cl minus. We have Br minus. We have I minus and OH minus. Now, if you look at this now, this is for the cations, this is for the anions. Now, if you check their reactivities, the ions that are above, for the cations now, the ions that are above, they are more reactive than the ones that are down. They are more reactive than the ones down here. Likewise, the same for this. Now, when we are saying position of ions in the electrochemical series, if you have, after the ions must have migrated, for example, let's use these two. Now, what are we considering? Electrolysis of sodium chloride solution, aqueous sodium chloride solution. Now, if you check this now, we have Na plus and H plus. Both of them are migrating to the cathode because they are positively charged ions. Now, out of these two, which one will be discharged at the cathode? So you now come to your factors. You'll be considering all these factors. Now, we have factor number 1, position of the ion in the activity series. Now, when you have, check the ions that you are dealing with and then check the activity series. The ions that are below in the activity series have a higher chance of being discharged at the expense of those ones that are above. Now, for example, sodium chloride solution. So the aqueous form. Now we know that what's the first step? Ionization. If you ionize, give the ions Na plus, Cl minus. Then you have water, H plus or H minus. Then the second step, migration of ions to the electrode. These two, sodium ion and hydrogen ion, they migrate to the cathode, and then chloride ion and hydroxide ion, they migrate to the anode. Now, the next thing, considering concentration. Let's say this is concentrated NaCl. We are dealing with concentrated sodium chloride. Concentrated sodium chloride. Because sodium chloride is concentrated, the concentration of the ions will matter. How does that happen? Now, this is what we check. Check the ions that you are dealing with, and then check their position in the electrochemical series. Check how close they are in the electrochemical series. If the ions are close, the more concentrated ion will be preferentially discharged, and not the position of the ion anymore. Now, for example, now we have Na plus and H plus. Let's check the position of in the electrochemical series. Na plus is up, H plus is down. There is a far distance between them. But to make it easy for you, because it's jammed and then you need hints and then how to quickly, like some codes that you need to quickly get your job done very quickly. Now, this is what you will do. Check your electrochemical series or activity series. Check the space, the distance. Once the distance between the two ions you are considering is more than two things, like more than two other ions. Once the distance is more than two other ions, concentration will no more matter. Now, let's say we have Na plus and H plus. Na plus is here, H plus is here. Look at the ions between both of them. This. We have like 5. So, although NaCl is concentrated, because NaCl is concentrated, Na plus and Cl minus, they are concentrated ions because the NaCl normally is concentrated. So, the ions will also be what? Concentrated. So, but we are considering Na plus and H plus. Now, considering NH plus and H plus here, will concentration matter? No. Although NaCl is concentrated and Na plus here is concentrated, what will happen? Why is it that concentration will not matter? Because when we check the distance between Na plus and H plus, the ions that are in between them, they are more than what? More than 2. So it is only when they are close together, that's when the more concentrated ion will be what? Discharged. But if they are not close, you still need to go back to your position in the activity series. So the one that is below in the series will be what? Preferentially discharged. Now, let's say, for example, we are considering Cu2 plus and H plus. Let's say we are doing CuSO4 aqueous, that's copper 2 tetraoxosulfate 6 solution. Now, let's say it is a concentrated copper 2 tetraoxosulfate 6 solution. Now, what will you be getting here? Cu2 plus and SO4 2 minus, all of them in aqueous state. Now you have H plus OH minus. Now these two, they are migrating to the cathode. Now looking at Cu and H plus, the solution is concentrated, meaning that there is a high concentration of Cu2 plus from CuSO4 solution. There's high concentration of Cu2 plus. So what will happen is that Cu2 plus is here, H plus is at this place. Both of them, H plus is just above Cu2 plus. That means concentration will matter because the distance, they are very, very close. Both of them, both ions are very close. That means the more concentrated ion will be preferentially discharged. So which one is more concentrated here? Cu2 plus. So that means Cu2 plus will be discharged at the expense of H plus. So that's what concentration of the electrolyte does. Now you need to check the concentration. So if the electrolyte is concentrated, that means the ions that will be produced will be also what? Concentrated. Then you will need to check your activity series and see the ions you are considering. Are they close to each other? Are those two ions close to each other? If those two ions are close, the more concentrated ion will be what? Preferentially discharged. But if they are not close, let's say they are a distance of 3 or more apart, the one that is below in the electrochemical series will be discharged. Now to the third factor. The third factor is the nature of the electrodes. Nature of the electrode. In this part, we'll be talking about how electrodes, how they influence the preferential discharge of ions. Now, I'll be talking mainly about two different kinds of electrodes here. We have the active electrodes and we have the inert electrodes. Now, from the word inert is something that is, when we say something is inert, we mean that thing is like unreactive. Now, there are electrodes that are inert. That is to say, they just do their job of facilitating transfer of ions. They don't influence preferential discharge. And then there are some electrodes that are active, that apart from the fact that they are doing their normal job as electrodes, they also influence preferential discharge of ions. Now, for example, platinum electrode is an inert electrode. Platinum just allows the transfer or the migration of ions from one place to the other. It does not affect the preferential discharge. Now, an example of an active electrode is mercury electrode. Mercury is an active electrode. That's why you see that whenever you are doing electrolysis of anything that has sodium, for example, electrolysis of maybe concentrated sodium chloride, which is brine, or electrolysis of sodium hydroxide, mercury electrode has affinity for sodium. So irrespective of position or concentration, once you are using mercury electrode, it goes to pick what? Sodium. So when you are using mercury electrode, sodium will be liberated, will be preferentially discharged, like in all cases, because of the electrode you are using. So if the electrode is active, it will influence the discharge of a particular ion. But if the electrode is inert, it will not influence the discharge of any ion. It will just do its job of facilitating movement of ions from one side to the other. Now, so having known all these factors that affect preferential discharge of ions, let us try some examples to explain what we have been saying since. Now let's do like 3 examples. So I'll be giving us, let's start with electrolysis of dilute sodium chloride using platinum electrodes. Electrolysis of dilute sodium chloride aqueous using platinum electrodes. So you need to check whatever they give to you, check the electrodes, check whether it is inert or active. So from this statement, we can actually deduce some important points. Number 1, we have been told that the electrolyte is dilute, meaning that concentration will not matter. Concentration is out, it will not be considered. Number 2, we have been told that what electrodes are we using? Platinum, which is what? Inert, meaning that it will not influence the preferential discharge of any electrode. It will not influence the preferential discharge of any ion. So what will be the only factor that will affect discharge of ion in electrolysis in this place? Position of the ions. So that's how you do your kind of elimination. Whenever you see questions, check the statements. So let's continue. So what is NaCl? You have NaCl aqueous. Is a strong electrolyte, and then because it's a strong electrolyte, the ionization is complete. So you have your ions being generated. From this step, what was the first step? Ionization of the electrolyte and water. So the electrolyte will undergo ionization. This one will give you Na plus Cl minus, aqueous form. Then you have your H2O liquid. That one, because it is so, this is going to be what you are going to be having. H plus OH minus. Number 2, migration of the ions to the electrode. The positive ions to the cathode, the negative ions to the anode. So what happens? Let's check the ions that will be preferentially discharged. Now, we have considered that from the statement, concentration will not matter because the NaCl we are using here is dilute. It is not concentrated. So the concentration of the electrolyte, that is not a factor that is going to be considered in the preferential discharge. So, and then we have always said that we are using platinum electrode. Let's assume that this platinum will replace it with mercury. That means nature of electrode will matter because mercury has affinity for sodium. So mercury will single-handedly pick sodium and then sodium will be discharged. But because we are using platinum, which is an inert, it does not affect. So that means we are only left with position of the ion in the activity series. So from what we have said before, the ion that is lower in the series will be what? That will be preferentially discharged. So we are discussing Na plus and H plus. From our activity series, Na plus is here, H plus is down. So meaning that H plus will be what? Preferentially discharged. So at the cathode, what? Hydrogen ion. So you need to write your equation. Don't forget that at the cathode, reduction occurs. So what's reduction? Gain of electrons. So this is the way you write it. 2H plus 2E minus to give you H2 gas. This is the cathodic reaction. Cathodic reaction. Now, from oxidation, you know that people believe that oxidation is addition of oxygen. That's correct. Anyways, and reduction is what? Removal of oxygen or addition of hydrogen. That's also correct. But also, oxidation is the process of, like when you say something is being oxidized, like there is, oxidation is like increase in oxidation number. Now, so if we check from here, what's the oxidation number of H plus that we have here? You can multiply this by 2, so you can call this one, this is plus 2. Then this one, the oxidation number is 0 because it's a single molecule, it's not combined. So 0, this plus 2 to 0. This is reduction in oxidation number. Are you getting me? Reduction in oxidation number, that means that that's what? Reduction. So it's happening at the cathode where reduction occurs. Now let's go to the second one, anodic reaction. Which of them will be discharged? This is chloride ion, this is OH minus. Let's check our series. Cl minus is here, OH is down. Because OH is lower in the series, OH will be discharged. So what is the equation? So at the anode, this is what you have. You are going to be having, I would like you guys to, this reaction that I'm going to write, I'd like you guys to put it in your brain. Just know it like that. This is 4 OH minus to give you 2H2O plus O2 gas plus 4E minus. This is the anodic reaction. So anytime they're asking you, you can see from the product that water is being formed and oxygen. This oxygen molecule, and this is water. So whenever you are doing any electrolysis question, and then they're asking you that, okay, something Faraday liberated something like oxygen. This is the reaction they're asking for. Just know it. 4H minus to give you 2H2O plus O2 plus 4E minus. So we can see that at the anode, hydroxide ion is being liberated. At the cathode, hydrogen ion is being liberated. Now, let's wait and see. So now, let's check this. That means at the cathode here, H plus is gone. It has been discharged. So it's gone. And then at the anode, OH is what? OH is gone. So what do we have? We have Na plus and Cl, which can combine, and then we are just forming our salt. We are forming our salt. Now, so you can see that this is like, from what we are seeing now, we can see that H plus and OH, they are being discharged, and then we are left with Na plus and Cl minus. Now, so the next thing is that we need to balance the reaction, because we need to balance the number of electrons, we need to balance the atoms and all. But from what I'm seeing here, we are only left with the electrons to be balanced. So this is 2E minus. So at the anode, we have 2E minus on the left. At the cathode, we have 2E minus on the left. And then at the anode, we have 4E minus. What do you do? Multiply this by 2. Multiply this one by 1. So that the electrons will cancel out. And then we have what we call a net ionic equation. So after joining everything together. Now, although that's not the important thing we are doing here. So what I just want you to get is that you should know the one that will be liberated at both, the one that will be discharged at both electrodes, and then the factors that guide. Now, let us do quickly another example. Let's change this dilute. Let's make it concentrated, and let's see what we are going to be having. Electrolysis of concentrated sodium chloride. Concentrated sodium chloride is also known as brine. B-R-I-N-E. It's also known as brine. So whenever you see it, B-R-I-N-E, they are talking about concentrated sodium chloride. Now, so if you follow the same thing, NaCl will give you Na plus Cl minus. Now, electrolysis of concentrated brine using platinum electrode. Now, check the statement. The electrolyte is what? Concentrated. Meaning that concentration of electrolyte will be a factor to be considered. Now, position of the ion in the electrochemical series will also be what? Considered. Then number 3, using platinum electrode. The electrode being used is inert. So that means nature of the electrode, we have no part to play. So what are we going to be talking about? Position of the ion, the activity trace, and then the next thing is the concentration of the electrolyte. So from what we have here, Na plus and H plus, we move to the cathode. Now, if Na plus and H plus move to the cathode, because H plus is lower in the electrochemical series, it's supposed to be discharged. But the electrolyte is concentrated, meaning that we need to pay attention to the concentration of the sodium ion that we have here. Now, but if you check our activity series, if you have not forgotten what I said the other time, I said you only consider concentration if the electrolyte is concentrated, and then if the distance between the ions the ions in question, if the distance between them is not more than 2 to 3 other ions. Now look at Na plus here. Na plus is here. Na plus is here. H plus is here. Look at the distance between Na plus and H plus. We have 5 different ions within the both of them. So that means that concentration we have will be useless in this place. That means we have nothing to do with concentration anymore. So that means what we are left with is position of the ion in the activity series. So we need to go for the ion that is below. So the one that is below is what? H plus. So meaning that